So we're going to revisit our old friend from Chapter 10, hypothesis testing, but this time we're going to do it for the difference between two independent proportions. And this is just a reference sheet that we'll refer back to as we work through the problem and find all sorts of answers and such. Okay, so let's look here. Apnea prematurity, defined as cessation of breathing that lasts for more than 15 seconds and is accompanied by hypoxia and bradycardia, occurs in at least 85% of infants who are born at less than 34 weeks of gestation. One therapy for this condition is to give caffeine to the premature infants. Medical researchers conducted an international study in which one sample of premature infants was randomly assigned to receive the caffeine therapy, and another sample received a placebo therapy. Researchers compare the rate of needing supplemental oxygen at 36 weeks between the two groups to determine whether the caffeine therapy group would need less oxygen than the placebo group. All right, so the caffeine group includes 963 infants, of which 350 needed oxygen at week 36, and the placebo group of 954 infants had 447 that needed oxygen at week 36. Well, that's a lot of information, but this is the kind of stuff that can show you where our statistics can get really applied to real life data and real life studies. And yes, this is a real life study. Okay, so we're going to say group 1 is the caffeine group right here. So if we look up here, the caffeine group had 963 infants, of which 350 needed oxygen at week 1. So if we think about p hat for group 1, which is the caffeine group right here, then p hat is x1 over n1. x1 was 350. Remember, x is always smaller than n because proportions have to be less than 1. So 963 was the entire group for those infants. And then we need to find that to, let's say, 3 decimal places. Okay, so let me go grab Desmos and find what that is. So 350 divided by 963, and we get 0.363. All right, now for p hat for group 2. Group 2 was the placebo group. They had 954 infants, of which 447, needed oxygen. So that's x2 over n2 would be 447 over 954. Sorry, I misread that number. So 954. Okay, so we need to know that decimal. And we need the decimals for later. We don't actually need them right this second, but it's common to want the decimal. All right, so we get 0.469, call it, right? Because that 5 would round that 8 up. So we're going to say about 0.469. All right, this is the placebo group. Now it didn't ask for it, but let's go ahead and find our Q hats as well, because we're going to need them down below. So Q hat for group 2, remember, is 1 minus the P hat. So that's 1 minus 0.469. So let me find what that is. So 1 minus 0.469 would be that, and 1 minus 0.363 would be 0.637. All right, so now we know this is 0.531, and then this one, Q hat for group 1 would be 1 minus 0.363, which is 0.637. Okay, so we have our p hats, which were what was asked for. Right here, I'll circle those. And we have these q hats that we might need for later. Now, hypothetically speaking, what is the good outcome for the premature infants at 36 weeks? So not needing supplemental oxygen would be good, right? Because that would mean that the baby is breathing well. So that's just something to keep in mind for how we want to think about this. You might also notice this graph. You can see there's a large difference between the oxygen group and the no oxygen group for caffeine versus placebo. So I imagine when we run this test, it seems like because this has a big disparity, I bet you that means that we are going to show that there is a difference. And then we're going to reject H naught. But of course, we have to prove it. All right, but before we can get to proving it, we need to verify requirements. And there are a lot of requirements to to verify in this chapter because there's more than there usually were. So we need to know that it's a random sample, which that part's easy because it was given. And then we need to know that these samples are independent. So random samples actually, and it should have said somewhere up here, but these were random children, and they randomly assigned them to the treatment. All right, so we'll just say, yes, it's given, right? It mentioned random assignment and various other things up there, so we're good. Of course, you can't make babies randomly premature. That doesn't work, but it does say right here that they were randomly placed, so we're good there. Now we need independent samples. Now this is new. This is new to this chapter. We did not have this in chapter 10 because in chapter 10 you're only dealing with one sample. So I'm going to make a little note that this is new, right, for chapter 11. Give a little star. All right, that is because they're two separate groups. So this is yes, because they're two separate groups of infants measured once. And you have to have both pieces of that there. You can't just say that they're two separate groups. You have to talk about how they're measured only once, because if they were measured twice, that would be a different thing. And it's actually an important thing to note right here. I'm actually going to mention this. Placebo and treatment groups are always independent. That's kind of the whole point, is that they've been randomly placed into groups that don't mix. So when you have a treatment like a caffeine therapy and a placebo group, those are always separate. Right? That's how design experiments work. So just a little note right there. All right, that's the new piece. Now we have some more of the old piece. We need to know that these samples, which were independent of each other, are independent of the population. All right, for that, we need our old standby. We need to know that n is less than or equal to 0.05 capital N. But we're actually going to do it for two groups. So let me separate my paper a little bit here. So I need for group 1, I need N1 to be less than or equal to 0.05 of capital N1. Well, little n1 was 963. So 963 is less than or equal to 0.05, and then these are premature babies, right? This is all preemies. Preemies is just a short way of writing it. And then we need to know the same for group 2. We need little n2 to be less than or equal to 0.05 capital N2. Well, indeed, 954 is less than or equal to 0.05 of all preemies. Okay, so we've shown normal for both, or excuse me, independent, excuse me, not normal, independent of population for both groups. Now we're going to show normal. Okay, so normal is going to be right here. And normal we've also done many, many times. That's the n times p times q, or p hat times q hat in this case, is greater than or equal to 10. So we're going to have to do that for both of our groups. So we need n1 times p1 hat times q1 hat to be greater than or equal to 10. n1 was 963. We're going to multiply that by p1 hat, which is 0.363, and times q1 hat, which luckily I had us find, that's 0.637. And we're going to get a number, and we're going to hope that it's bigger than 10. So, and it is, but I'll prove it. Okay, so 963 times 0.363 times 0.637 makes 222.6, right? Or 222.7, I should say. So 222.7, I'm going to have to write it down here, is greater than 10. So that's a yes. All right, now we're going to have to do it again for group 2. We need n2 times p1 hat, or p2 hat, sorry, p2 hat times q2 hat to be greater than or equal to 10. N2 was 954. P2 we found to be 0.469. Q2 we already found to be 0.531. So we need to know what that number is. So let me go back to Desmos. All right, 954 times 469, sorry, times 0.531, and we get 237.6. Well, 237.6 is indeed greater than or equal to 10, so we're good. We have verified all requirements. So this is a yes for everything. So now let's run the test. We want to perform a hypothesis test to determine whether the caffeine therapy was effective in lowering this supplemental oxygen rate for premature infants at the 0.01 level of significance using the p-value method. Well, that's the only method we use anyway. Okay, so step one, we need a null and an alternative hypothesis. Now, the beauty of chapter 11 is that they're not equal to any particular value. So you don't have to go hunting around and trying to figure out what it was. Your null hypothesis is always that the groups are equal to each other, that there's no change in the groups, that the caffeine group is equal to the placebo group. And then your H1 would be the caffeine group, right, which was group 1. Remember, that's caffeine right here. That was the caffeine group. And it says, was caffeine effective at lowering the supplemental oxygen rate? Okay, so we want the caffeine group to be lower than the placebo group, which is this group right here. And that's it. Step 1 is done. Now, I will say that there is another way to write these. This is the way we write them by hand. So when we're writing these by hand, this is what we do. In StatCrunch, what they do, and in a lot of computer programs, because it's just easier, they subtract the P2. So you say P1 minus P2, and if you subtract P2, it's 0 over here, right? Because if they were equal to each other, then when you subtracted them, you would get nothing. And then H1 would be P1 minus P2 is less than 0. So this is how StatCrunch and other computer programs write them very often. So either one of these is fine. We tend to do this one on the left more often, but it's fine either way. All right, so step 2, what's our alpha? Well, our alpha was given. It's 0.01. That's our level of significance. Step 3. Well, step 3 is, actually I'm going to put step 3 right here. If we look at our sheet, it says, right, state the test statistic in the StatCrunch output, and it's Z0. And step 4 is going to be to draw a picture. So we're going to get Z0 right here, and this will be actually step 4. I'm going to draw a picture of a Z curve, i.e. a standard normal curve. So it's going to look like that. Okay, so where do I go in StatCrunch? Well, the instructions are right here at the top. Stat, proportion stat, to sample with summary. So that's where I'm going to go. I'm just going to open a blank StatCrunch right here. Oops, I have to sign in. There, now I will open a blank StatCrunch. Stat, proportion stat, to sample with summary. And then we put in our x's and our n's, which we wrote down in part A. So the x for group 1 was 350. And then the n for group 1 was 963, right? You always have to remember this is x, this is n, right? Successes is x. We learned that in section 6.2. 447 and 954. We're running a hypothesis test. Notice StatCrunch kind of writes it with a subtraction notation. We want to change this to a less than. And then just like in chapter 10, we want to turn on that p-value plot because that'll be step 4 for us. So you want to make sure you have a hypothesis test and a p-value plot. That's all you need. And then say compute. And there's a lot of information on the first page, but honestly, everything we need is on the graph page. It's all right here. We can see the graph, we can see the z-stat. So the z-stat, where it says that, is negative 4.6686. That is our step 3. And then the graph, well, it's really far out there. So we're just going to shade a little tippy tip on the left-hand tail and then label it. So this is z-stat from StatCrunch. This is that same z-stat. So that's z0, and we're going to label it with its letter and its number. And then we're going to say this little tail over here is the p-value. Well, the area of it is the p-value, which was less than 0.0001. All right, so now it's decision time. We have to make a decision. Now our decision is going to be based on our p-value. So our p-value was less than 0.0001, which is certainly less than our alpha, which was only 0.01. So whatever the p-value is, it's got a lot of zeros, which means we're going to reject the null hypothesis. And that means that there is sufficient evidence to support the claim that the caffeine therapy was effective in lowering the supplemental oxygen rate. Remember, wherever this word is often the claim that you're trying to prove with your H1. So I'm just going to write that up real quick. There, I just wrote it up. So there is sufficient evidence to support the claim that the caffeine therapy was effective in lowering that supplemental oxygen rate for premature infants. I basically just stole what was written in the problem, where the word lowering was, and that was perfect for our claim.